Okay, guys, this is day 5, year-end review of proportions. Okay. First question is it proportional? So what you have to remember is we used that rule that said, basically, look, if you have A over B and C over D, that what you should see, if they are proportional, you should be able to use the cross products or means and extremes and be able to say that A times D equals B times C. That's your test. Okay, that was the test for the whole thing. And it means they're equivalent ratios. So if I look at this, then if I look at this problem 3/4, I'm going to take 4 times 9, which equals 36. And then I'm going to look at 3 times 12, which is also 36. So these two are equivalent. So therefore, yes, it is equivalent. They're equivalent ratios. That's all you had to do with it. So when we look at the second set of fractions, we're going to do the same thing, because when it says they are proportional, what that means is we're going to put an equal sign there. That's what we want to know. Are these two equivalent? Okay, so again, like we said, what we're going to do is we'll do the 7 times 4, and we'll do the 1 times 35. Well, 7 times 4 is 28, and 1 times 35 is 35. Well, these two are not equivalent. So since their cross products aren't equivalent, then this is not a proportional relationship. Okay. Again, we're going right off of what we talked about with this proportion right here. Is that's if that's true, it's a proportional relationship. If you can't say that about it, it's not a proportional relationship. So we're going to use that same rule here. So when we're looking at this, but what we don't know is we're trying to find what this missing value is. So we want to know, what would this be? Okay, so what we taught you to do was, there's 3 ways to do that, because we could solve for the variable. If we put an x in there, we're just trying to figure out what x is, right? If we're trying to figure out what x is, I've taught you 3 different ways to solve this proportion. You could look at this and say, well, scale factor, but that's not going to be very easy, because 4 times 4 is 16, but what times 4 would be 5? Now, some of you may have figured that out in your head. We could solve for x, or we could just go ahead and do the cross products. So if I look at this, I'm going to take 4 times 5 is supposed to equal 16 times x. That's the rule, right? That's this rule that we've talked about. All right, so now all I have to do is solve this. So now I just solve for x, which you just got done with the test. This is basically simplifying a one-step equation. So I look at 4 times 5, which is 20. And this is still 16 times x. So I'm going to divide both sides. To solve for x, I'm going to divide both sides by 16. Now, this isn't an easy one necessarily, but what we wind up with is x equals 20/16, which reduces to 5/4. So that's got to be, so 5/4 equals x, right? So x equals 1.25. Again, we just use the cross products because that was the simplest way to do it. There's 2 other ways to solve it, but that was the simplest. Okay, so when we look at this one now, so this is on a map. Okay, on the map, 8 centimeters represents a distance of 24 kilometers. So we can rewrite that ratio, and they want to know what this would be, what the 1 would be. So again, we're going to write out our proportion. Our proportion is at 8 centimeters. and then over kilometers. We're going to have to keep things the same, right? 8 over 24. Or we could write it as 8 and 24. And if we look, this is really our scale factor here is we multiply 8 times 3 to get 24. They want to know, well, what would you do for if you were talking 1 centimeter? What would the kilometers be? Okay. Well, like we said, we're just going to multiply times 3, right? So that means you're going to have 1 times 3, which is 3. So that means you have 1 to 3. That's your ratio. Remember, a ratio can be written like this. A ratio can be written like this. Those are both ratios. Okay. A lot of you will call this one a fraction, but that's a fraction sometimes, but it's always a ratio. Okay. Okay, here we go. Let's move on to the next one. Okay, so this is building off that same thing. So if we're looking, you've got to say 4 over 160 equals 2 over something, which is going to equal 1 over something. Now, some of you are looking at it saying, I can just reduce that fraction. And you're right. Because if I look, my scale factor to move from here, from the 4 to the 2, I have to multiply times 1/2 or divide by 2. So if I just divided this by 2, I'd get that's 80. And if I check that, I could use cross products and say, well, 160 times 2, does that equal 4 times 80? Well, 160 times 2 is 320. 4 times 80 is 320. So yeah, that is equivalent. Okay, and you might look at this and say again, oh, well, but look, I'm just dividing by 2 again to get from 2 to 1. So divide this by 2 again. That'll give you 40. And again, you can check that. You can look and say, well, 80 times 1, is that equal to 2 times 40? So 80 times 1 is 80, and 2 times 40 is 80. Yep, that is equivalent. So when I fill this in, what I realized was this has to be 80, and this is going to be 40. There, I'm done. And everything was built off of this proportion. That's what we're doing. We're saying, are these two proportional? Okay, so when we look at these, again, we are just talking about proportions. We're going to use this relationship with both of these. So it says that Irene is running from Michael in a game of tag. Irene runs 6 meters every 2 seconds. Michael runs 30 meters every 5 seconds. What's Irene's speed in meters per second? So basically, we're just setting up this proportion that for Irene, she moves 6 meters in 2 seconds. And we're trying to figure out the unit rate, so we're going to figure out how many meters will she move in 1 second. And so let's say you don't get scale factor, because some students don't. We're just trying to figure out this. And if you don't see that right now, what the solution is, you can always use that cross product we were talking about. So you're going to say 2 times x is going to equal 6 times 1, which means we're going to have 2x equals 6. Then we're going to divide both sides by 2 to solve for the x. we get x equals 3. That means this is a 3. We would put a 3 meters in here. So you would write 3, you would type in 3 meters. Remember, you wouldn't put in the meters because that would probably just mess them up. Okay, she's moving 3 meters per second. And remember, we're just trying to figure out what the unit rate is. The whole unit rate is what they want. And now they want us to do the same thing with Michael. So again, we're going to say, well, Michael can travel 30 meters in 5 seconds. How many meters for 1 second is that for Michael? And we don't know, so we're going to put let's just put a y there, okay? Okay, so if we're going to solve that, then now what we're going to do is, let's look at another way. You could use cross product. You could use scale factor with this. I'm just going to look at this and say, well, this is y divided by 1. So what's 30 divided by 6? Because this is already y. What's 30 divided by 5? 30 divided by 5 is 6. So that means this is 6 meters per second. So you would write, he's moving 6 meters per second. Now here's the question. We're saying Irene runs 3 meters per second. And that we're saying that Michael runs 6 meters per second. And the question is, who's the fastest? So why don't you pick one and let's see if you know what you're doing. Okay, we're going to pause it for a minute. Okay, and so hopefully you said that Michael's the fastest because he moves the most meters in 1 second. And that's why we use unit rates, is to be able to compare things, okay? All right. Okay, so when we look at this one, convert the following description to a proper scale ratio. 2 centimeters represents an actual distance of 14 meters. Okay, so when we write scale out in this, we're going to be saying, we always want to know, what's 1 centimeter equal, because that's what we're drawing. So if we're doing a drawing, we're asking that. And if we're asking a ratio, we could write the ratio one of 2 ways. We could write it like this: 2 centimeters is 14 meters. Or we could write it as, 14 meters per 2 centimeters. Okay, so if I'm writing it out as a ratio like this and in a fraction ratio, then what I'm looking at is I'm going to ask, well, what is 1 centimeter? And I don't know that yet. Okay. Now, hopefully you've already seen it, you've anticipated it, but if you haven't, you can use, again, what we just said, because we have 1 centimeter here on the bottom. So really all we want to do is just to divide 14 divided by 2. And 14 divided by 2 is 7. So that's what x would equal. If we needed to, if it was different numbers than these, you could go like this and use your cross products and say 14 times 1 equals 2 times x. And then we're going to get, this is 14 equals 2 times x. I'm going to divide both sides by 2 and get x equals 7. So this ratio is the same as saying 1 to 7. And we could also say 1 centimeter equals 7 meters. Now, this is how I would write it if I was doing a landscape design. And that's where it's useful. That's where scale is used, is when we're drawing graphs, or if you're doing a puzzle. Puzzles are always to scale. Okay. All right. Okay, so on this one, it says the ratio of boys to girls is 20 to 188. So you have to be careful of this because a lot of you will make the mistake of not paying attention to what they're saying. So it's boys, so these are boys and these are the girls. Okay, so you have 20 over 188. And I would always tell you, write this down, boys to girls. Okay, and what we want to know is that's equal to if there are 47 girls. So that means we have to put the 47 down here where the girls are. And then we're going to try and figure that out. Okay? And so now it's just saying now if it's proportional, it's a proportional relationship. And that's the ratio. And now what we have to do is calculate, well, we're going to have 47 girls. How many boys are there? So we just do this, do the cross product. We get that 188 times x equals 20 times 47. So 20 times 47 is going to be 940. And then we still have the 188x. So now to solve that, we're going to divide both sides by 188. Which means x equals 5. So again, if we're going to go answer the question was find the number of boys. So if there are 47 girls, there are 5 boys. That's our answer. Make sure you're writing out your answers. Okay. All right. Okay, guys. So on this one, again, we're just gonna we have to read the question. It says the ratio of chairs to tables is 9 to 7. So you want to remember this is your chairs and these are your tables. Because they told us chairs to tables. Okay, and then they give us that we have 36 chairs. How many tables are there? So we're going to go back and just set up that proportion again. So they give us 9 to 7. So we're going to write down here, we're just going to keep track of everything, keep everything that's on top. So we have chairs over tables. Okay, and they gave us these original ratios, right? So original was 9 chairs to 7 tables. And then they give us that we're going to have 36 chairs. And we got to figure out how many tables we're going to have. Now for me on this one, I'm going to use this principle, but I've taught in class to use scale factor. So I'm going to use scale factor and say, well, 9 times 4 is 36. So T must equal 7 times 4, which means T equals 28. Now, some of you may say, well, I prefer to use the cross products. That's fine. So you would have done that. And you would have said that 9 times T equals 7 times 36, which means 9T equals 252. Then you're going to divide both sides by 9 to solve for T. So you get 1T, which means T equals 28. Okay, so again, this method that we used over here is different than the method I used on the left here, but they're using the same principles. That the bottom line is we're saying that two things are proportional. And this was our proportion. And we're going to solve it. And there's usually almost always there's more than one way to solve something. So the bottom line with this is we're just looking to set up proportions when it talks about a proportion. We're doing the same thing when we do the percents, which is what we're going to learn about next. Okay? So here you would say there's going to be 28 tables for those 36 chairs. Okay, good luck with this.